Today in the workshop, we'll be working with XOD, a method of programming in Arduino without writing any code. After learning how XOD works and building an improved version of the blink sketch, we'll be building a temperature humidity gauge that can switch between Celsius and Fahrenheit. We're working with XOD today, so welcome to the workshop. Hey, welcome to the workshop. Today is a very special edition of the DroneBot workshop in that we're going to learn about a new programming language for programming your Arduinos. Now the language is called XOD, which is spelled XOD, and I need to let you know that this is a sponsored video from the folks at XOD. Now they got in touch with me and asked me if I'd be interested in doing some videos on XOD, and after looking at the language and seeing what it could do, I readily agreed, because this is really a different way of programming in Arduino that I think a lot of you are going to really like. Now XOD is a free open source language that allows you to program in Arduino without writing any code. What you do with XOD is that you take little nodes, which are little blocks, and connect them together with little links in order to create a program. Now there is a desktop client for XOD as well as a web client, and I'll be going over the difference between the two, and I'll show you how to install the desktop client. Now what we're going to do today is we're going to do a couple of demos with XOD. After I explain to you the principles behind XOD, I'm going to start off with a very simple demonstration, one where we just basically flash an LED, similar to the blink sketch that everybody started off learning the Arduino IDE with. Now after that, we're going to move on and do something much more complex with XOD. In fact, we're going to take a project that we worked on in a recent video, and we're going to rebuild it with XOD, and we're even going to improve it. So I want to show you that right from the beginning you can write some fairly complex code with XOD, again without doing any code writing whatsoever. Now, am I advocating using XOD instead of the Arduino IDE? Not necessarily. I don't think that you should abandon the Arduino IDE in any way. What XOD is another tool for your toolbox. Think of the way that you're programming in Arduino in the way that a carpenter would work with different tools. A carpenter will have different types of saws for sawing different materials or sawing different shapes in different materials. And XOD is just another method of programming in Arduino. You'll still use the Arduino IDE for many applications. Another way to think of it is like with the tools I've got behind me on the pegboard in the workshop, which I'm sure you've noticed before. For example, over here I have a series of pliers. Now when I go to work on something, I may choose one plier over another set of pliers. It's not that the other set wouldn't work, it's just that the one I chose is more suited to the job that I'm doing. So XOD is just another tool in your Arduino programming toolbox. So we're going to begin by looking at what XOD is and how it works, and then I'll show you how to install it, and then we'll get into our demos. So let's take a look at XOD. XOD is a graphical method of programming in Arduino. With XOD you use visual objects instead of using text like you do with the Arduino IDE. The objects we use in XOD are called nodes. Nodes are small boxes with little circles on them. Each of these circles is called a pin. The pins on the top of the node are the input pins. The pins on the bottom of a node are the output pins. The outputs of a node can connect to the inputs on another node. The lines that we use to connect the outputs to the inputs are called links. Nodes can represent many different things. Some nodes represent common pieces of hardware. Nodes can represent binary and byte operations. There are many core function nodes in XOD. Nodes can also be used to convert data between two different units. The working area in XOD is called a patch. A XOD program can have one or several patches. You can even use a patch as a node within another patch. So now let's start working with XOD. Now to begin working with XOD, the first step is to go to the XOD website, which is XOD.io. Now this is an excellent website, and they've got all sorts of details about what XOD is, as well as links to documentation, more libraries for XOD, and community links, including a forum, which is an excellent resource if you're having problems with XOD. I encourage you to go through the documentation, especially the tutorials that they go through in order to understand XOD better. But the first thing we want to do is go to the IDE. Now if you go to IDE, you'll see you have two choices: to launch the browser IDE or download the desktop IDE. I'll explain the difference between those in a moment, but let's look at the desktop IDE right now. So I click on that and I go to a download page where I can download the latest version of the desktop IDE. The big green button will let me download a version for Windows. But if I have a different platform, just underneath the button I've got a link for the Mac OS, Linux RPM files, and Linux DEB files. Now if you're using Ubuntu Linux or if you're using Raspbian on the Raspberry Pi, you'll want to take the DEB file. If you're using a Red Hat derived version of Linux, such as Fedora, you'll want to take the RPM file. Now you can also use XOD by launching the browser-based IDE, which I have opened in another tab over here. Now the browser-based IDE functions identically to the desktop client with two exceptions. First of all, on the browser side, you are limited to the number of compiles you can do per day. It's generally 1,000, so that's really not too much of a limitation. But the biggest limitation with the browser-based client is you cannot deploy the code directly to your Arduino. You can still work with the browser-based client. If you go into Deploy and do Upload to Arduino, it won't work because you can't connect to an Arduino. But if you do Show Code for Arduino, you will get a code listing. And this is the code that actually needs to be typed into your Arduino IDE. So you can copy all of this by highlighting everything and copying it, and then paste it into the Arduino IDE into a blank project and upload that to your Arduino. Personally, I think that's an extra bit of hassle, and so I'd much rather use a desktop client. But there are uses for the web-based client. For example, if you're working on a XOD project in two different locations, say at home and at work, you might prefer the web client so that you can just stop at one location and pick up on a browser at another location. Of course, the web client would also be useful for those few machines that don't have XOD clients available. So if you have, for example, a tablet or something that you want to use, you could use that with the web-based client, and then again copy your code over to a Arduino by doing the deploy that way. XOD files are saved as what's called a XODBALL file. So you could also take the XODBALL file that you create in the web-based client and use that on the desktop client. But by far, I would suggest that you take the desktop client by downloading it and installing it on your computer. So go and do that, and I'll meet you back here and we'll start working with XOD. Alright, let's start with our first demonstration. Now this is a very simple demo that will just show you the principles of working with XOD. But you're going to see that very quickly XOD becomes a lot easier to use than the Arduino IDE, even for a simple demonstration. Now, what I've done over here is I've wired a couple of potentiometers up to two of the analog inputs on my Arduino. I've also wired an LED up to the Arduino, but the LED is optional because it's connected to pin 13, and most Arduino boards have an onboard LED on pin 13. The only reason I wired this was because I wanted you to be able to see it on the camera, and it's a little difficult to see the onboard LED. Now, the wiring for this circuit is as follows. I've taken one potentiometer and I've tied 5 volts to one end of it. The other end of the potentiometer is tied to ground, and then I've taken the wiper from the pot and I've tied it to analog input A0. Now, at the second potentiometer, I've taken again 5 volts and tied it to one side and ground to the other side, and I've taken its wiper and tied it to analog pin A1. And as I said, I've also wired an LED to my circuit. I've taken pin 13, fed it through a 220 ohm dropping resistor, attached that to the anode of an LED, and I've grounded the cathode. But again, you don't need to do this because there is an onboard LED. So now that you've seen how I've wired this, let's start working with XOD. So I've opened up the XOD IDE, and when you first start it, it opens up with a project called Welcome to XOD. And this project consists of a number of different patches. Most of the patches have comments on them and a couple of nodes. This one has one particular node on it over here. Now, the project browser on the side over here lets you manipulate your project. The very top of it shows you all of the different patches in your project. So if I expand that, I can see that this project has quite a few patches. Many of your simple projects will only have one patch. Below here are the areas where you can get different nodes for your patches, and it's filed into a number of different categories, and we'll look at that in a bit more detail. Down here is the inspector now. I've highlighted my LED, and so this is giving me the properties for the LED. So every time you highlight a node, its properties will appear here in the inspector. Now on this side, what I'd suggest you do is you click on this little question mark, which will open up the help screen. Whenever you highlight a node, it'll give you details of what all the different pins on the node do, and this is actually a very useful thing to keep open, so I'm going to keep that open for my project. Now I'm going to start a new project so I can manipulate the LED that's on my Arduino. So let's go to File and do New Project. And it starts a new project. And the new project will start with one patch, which by default is called Main. And that's the only patch I'm going to use in this particular project. Now, my project is to control an LED, so the first thing I'll need is an LED, and that's in the Common Hardware section. So I'll expand that and scroll down until I see an LED, and I'll drag the LED onto the patch. You can place it anywhere you want, and you can move it around. Now the LED is highlighted, and in the help I get a number of bits of information about the LED and what the different pins are. The port is the number, and the LUM is the luminosity. Now the port refers to the connection on the Arduino. Now my LED is connected to pin 13, so I'm going to type a 13 in over here. Now, the LED is called LED, which is pretty descriptive, but if you have several LEDs in your project, it might get confusing, so you can also give it a name. I'm going to call mine the onboard LED. Okay. And so now it's the onboard LED. Now, the luminosity of the LED is its brightness. Now I've used port 13 or pin 13 on the Arduino. Now pin 13 is not capable of pulse width modulation, so I only have two brightnesses, either fully off or fully on. However, if I'd had used a pin that was capable of pulse width modulation, I could actually set the luminosity to a value somewhere between 0 and 1 and control the LED's brightness. But for right now, it shows me that my LED is set to 0, and 0 is off. So I'm going to set that to 1 right now. And that should turn the LED on once I load the program up to the Arduino. So let's do that right now. I'm going to go to Deploy and do Upload to Arduino. Now it finds the Arduino connected to my machine. There is a checkbox here, by the way, that says Compile in the Cloud. You can use your online XOD account to compile this program using the cloud server instead of your own computer. However, I'm going to use my own computer. If you have a very weak computer, you might want to consider using this. And I'm going to hit Upload. Now the deployment is indicated down here by a status bar. If you click this little arrow here, you can actually get more information about it. And I've uploaded successfully. And so if you take a look right now, you'll see that my LED is on. Remember, I've connected an external LED to pin 13 just so that you can see it, because the onboard LED is a little difficult to see here on the video. Okay, well that was great fun, but obviously just controlling an LED and turning it on isn't very useful, so let's do something with it. Now the classic Arduino sketch to try the first time is blink, so let's try to rewrite blink using XOD. So I'm going to go back up and just minimize my common hardware. I'm going to go to the core. Now a good way to blink this would be to use a square wave and feed it into the LED's luminosity port, and that's what I'm going to do right now. Here's a square wave, and I'll drag the square wave into here. Let me just move my LED down a bit over here, and I'll move my square wave over here. Now let's take a look at the square wave. It has a number of different pins on it. T is the time, the period that the square wave is going to go, and it's set to 1, which is 1 second. Duty is the duty cycle. Now, if you're not familiar with duty cycle, it's the ratio of the time that the square wave is high versus the time it is low. 0.5 means it's a perfectly square wave, and we'll work with duty cycle a little later. Then we've got a couple of other lines here. Enable, which is a Boolean, which says whether this square wave generator is enabled or not. A reset, and the output of the square wave itself. So what I'm going to do is I'm going to tie the output of this to the luminosity input on the LED. And I'm going to do that just by dragging a line onto that. And that line is actually called a link. And so as you can see, I've connected the two. Now if you go back and look at the LED, you'll see that the only thing I have here is the port. My luminosity is now being controlled by the square wave, the output of the square wave. So I can't put a value here because this is going to control it. And so now what I'll do is I'll save my program. It's a good idea to save my program. And let's call it LED blink. And I'm going to deploy that to XOD now. Okay, and now if you take a look at my LED, it is blinking. So we've rewritten the blink sketch quite simply over here with just 2 nodes in XOD. Okay, that was great fun, but you'll notice I put a couple of potentiometers onto my board, and I'll show you what I've done that for. We're going to take blink, and we're going to soup it up a little bit over here. So I'm going to go and close these core elements here, and go back into my common hardware. And I'm going to take a pot. Now here's the pot. And the pot I've got connected right now to analog port A0, so I'm going to leave that as 0. Now the value of a pot can go anywhere from 0 to 1 when it's rotated. I'm going to name this too because I've actually got 2 pots, as you recall, on my experiment, so I don't want to get them confused. I'm going to call this one the speed because I'm going to control the speed that the LED blinks with it. Okay, so I've got the speed. I'm going to take its output, which is its value, and connect it to the T input on the square wave, the time period. So I can vary it between 0 and 1. And I'll save my project, and then deploy it. Okay, so as you can see, my LED is blinking a bit faster now. This is the pod I've got connected to analog A0. If I move it down over here, you'll see it goes faster and faster until the point that it's blinking so fast that I really can't see it with my eye. So very fast blink. And if I go all the way to the other end, which will give the pod an output value of 1, I'm back to the original blink speed. Now this is pretty nice, but actually it's got a bit of a problem. You'll notice when I go to this end over here, it blinks so fast that I can't even see it, so it's rather pointless. And on this side, it's only blinking once per second. I'd really like to actually extend that. So let's do that. I'm going to close my common hardware and go back into my core. And I'm going to take a map range. Now, for those of you familiar with the Arduino's map command, this is sort of the equivalent of that. And there's several values over here in the map. Now, right now I've got my minimum and my maximum value, which are the input minimum and maximums, and the output minimum and maximums are these T values over here. So the input minimum I'm going to leave as 0. The output I'm going to be as 1 because my pot is going from 0 to 1. And here for a minimum, 0 seems to just blink that thing so quickly I can't see it. So I'm going to do 0.1. Remember, you can use fractional numbers in XOD. And the output, I'd like it actually to go a little slower, so I'm going to give it an output of 4. And you can play with these values yourself, by the way. So now what I'm going to do is I'm going to highlight this link and just hit my delete key. And that removes it. I'm going to take the output of this, move it to T, and I'm going to take the val over here and move it to X. Now let's just move that so we can see that a bit better. Okay, so I'm feeding this into the map range command, and I'm going to change the range that this pod is using. So again, I'll save my project and deploy it to the Arduino. Okay, it's been deployed, and now you can see this is in the mid position. It's blinking quite slowly. And as I move it up, it goes even slower because this is the 4 seconds. When I move it down to the other end, it blinks very fast, but I can still see the blink. So it's a good range. But one thing you might have noticed is, at least to me, this seems a bit backwards. When it's at this position on the far left, or the furthest counterclockwise, it's going fastest, and as I move it up, it's going slower. Now this may not be exactly what you want. Now of course there's one easy way to fix this. I could just reverse the 5-volt and ground connection to the pot and everything would be fine, but let's just do that in code instead. So I'm going to go back into XOD and go to my map range. And I'm going to change this minimum maximum to be the reverse. So I'm going to make this a 4, and this is 0.1. Now again, those of you familiar with the Arduino map command will know that you can do that with the map command itself. You can make it go backwards. Let's just save this and deploy it. And I've uploaded the XOD. Now, if I turn this up, it goes faster. And if I turn it down, it goes slower. So now I've fixed that. You may have noticed, of course, that I have a second pot on board, so let's make use of that one. I'm going to close the core and open up my common hardware again. I'm going to drag another pot on here. Now what I'm going to do is control the duty cycle with this pot. In other words, the amount of time the light is on versus the amount of time versus when it's off. So I'm going to just label as duty so I know what it does. And this one is connected to port A1. And I'm simply going to take its value and connect it to the duty cycle input on the square wave. And again, I'll save my project. And I'll upload it to the Arduino. Okay, it's uploaded. Now, this pot over here is the one connected to A1, so it should control my duty cycle. So at one end, you can see that it's off more than it's on when I turn it in this direction. But the rate is the same. That's controlled by the top pot. And at this end over here, it's on more than it is off. And so this pot is controlling the duty cycle. And so there you have it, our first XOD demonstration controlling an LED. I think you'll agree that if you had to actually write this sketch with the Arduino IDE, there'd be a lot more involved over here, especially controlling the duty cycle. And so as you can see, XOD is simplified doing this. Now, flashing LEDs is a lot of fun, but really it's not that practical. So what I wanted to do for our final demonstration today is show you how we can use XOD to build a real practical project. And what I'm going to do is rebuild one of the projects I worked on in one of my previous videos. You may recall the video in which we worked with liquid crystal displays and we built a temperature and humidity gauge. Well, I'm going to rebuild this with XOD, and I'm actually going to add a new feature onto the gauge and improve its performance. And so what we'll end up with is actually a project that you could put into a case and make a permanent project that you can use in any room of your house. Now, I've got it wired up over here again. It's essentially the same wiring that I used in the original project with one addition. In addition to the DHT22 temperature and humidity sensor, I've also added a push button and a pull-up resistor for the push button. And what the function of the push button is going to do is it's going to add one extra feature to my project. You'll recall the original project displayed the temperature in degrees Celsius. And as I mentioned in the article accompanying that project, if you'd rather display in degrees Fahrenheit, you could simply do a bit of mathematics and have your display come out in Fahrenheit. Well, I thought it would be nice to actually create a display that I could switch between Celsius and Fahrenheit, and that's what the function of the push button is going to be. So let's examine first how we've wired this project up, and then after that we'll go and we'll take a look at how we'll build this project up using nothing but XOD. To build our project, we'll need an Arduino Uno, a DHT22 temperature and humidity sensor, an LCD 1602 liquid crystal display with an I2C adapter attached, a push button switch, and a 10K resistor. We'll start by connecting 5 volts from the Arduino to the VCC connection on the liquid crystal display. We'll then connect ground from the Arduino to the ground connection on the I2C connector on the display. We'll connect the SDA connector on the display to the SDA connection on the Arduino. If your Arduino does not have an SDA connection, use analog pin A4. The SCL connection from the display will be connected to the SCL connection on the Arduino. If your Arduino does not have an SCL connection, use analog connection A5. Now we'll connect 5 volts from the Arduino to pin 1 of the DHT22. Pin 2 of the DHT22 will be connected to pin 7 of the Arduino. Pin 4 of the DHT22 will be connected to the Arduino's ground. Note that there is no connection to pin 3 of the DHT22. Now we'll run a connection from one side of our push-button switch to pin 2 on the Arduino. We'll also connect the same side of that push-button switch to the Arduino's 5 volts through the 10K resistor. This is acting as a pull-up resistor. Finally, we'll connect the other side of the push-button to the Arduino's ground. So now everything is hooked up and I'm in my XOD IDE. I've started a new project and I've got one patch again and it's called main. So let's add some of our hardware onto it first. We'll go down to the very bottom of the common hardware and we'll see a text LCD 16 by 2 I2C, and that's the connection we want over here. Now we're going to open that up, and again the help screen tells you a lot about the different pins that are attached to this. Notice that this is all input pins. There are no output pins from the LCD display, and that actually makes some sense. Now one thing we need to set, because this is I2C, is the address. And here's one little quirk about XOD you need to know. The address, which is in this field, is not in hexadecimal, which is how it's commonly expressed on an I2C bus. It's in decimal, and so you need to convert. So right now it's set to 39, which is hexadecimal 27, and that's a very common value for an I2C connection for an LCD. However, mine uses hexadecimal 3F, and that is the same as decimal 63 or 63. So I'm going to change that to 63 to match my LCD connection. Okay, and that's the only thing I need to configure in here for now. I'm going to move my LCD down a little bit further. I'll maybe give it a name, call it display. The name is entirely optional, by the way. Now the next thing I'm going to need to do is I'm going to need to bring my DHT22 onto here. And the DHT2X thermometer handles a line of DHT devices, including the DHT22. So I'm going to bring that on. And the only thing I need to set here is the port, the pin that I've connected it to on the Arduino. And so that's pin 7. Now there are two outputs on here. Let me highlight it again so you can see them. The RH is the relative humidity, and TC is the temperature in Celsius. Now if you'll notice, my display has a couple of lines, including line 1 and line 2. Those are two of my inputs. And so it's a very simple matter to start off by connecting my temperature down to line 1 and my humidity to line 2. Let's move that down over here for now. And I'll save my project. And it saves as a XODBall file. And I'll deploy it up to my Arduino. Now as you can see, I'm displaying two things. The top line is my temperature in Celsius, and that looks pretty good at 22.00. The bottom line is my humidity, which should be in percentage. However, as you can see, it's a fraction of 1. So although it's correct at 0.43, I'd actually like to have that read 43, as it is 43%. So let's fix that humidity reading. So what I need to do is multiply my humidity by 100. Let's just get rid of this line over here. Highlight it and hit delete. I'm going to go into my core over here. I'm going to get multiply. Now this is a multiply node. If we take a look at the multiply node, we've got two inputs and one output. And basically it multiplies the two inputs and feeds it to the output. So my output right now I'm going to connect to L2 because I know that's where it's going. And input number 1, I'm going to take my relative humidity, put it to there, and then I'm going to make my multiply factor 100, so that will take the place of input number 2. And we'll save my project and deploy it. And so now you can see in my project that I've got my temperature and my humidity displaying a bit better. In fact, I've got a bit more accuracy out of my humidity over here. Okay, well that's very good, but of course it's not that meaningful a display. I've got my temperature and humidity, but I really don't know which is which. So let's do something about that. I'm going to break these connections here. Just move my display down a bit more so I can get some more stuff in here. I'm still in the core. And I'm going to bring these two in. They're called concat 3. Concat means concatenate. And the 3 means I'm concatenating 3 different things. To concatenate basically means to take a string and to join it up several different strings to make one string. Now I'm going to connect the output here to input 2. So my inputs on the concatenation are basically the first, the second, and the third string. And there, as you can see, there's concat 4 and concat 5 and concat 6 as well. Plus a concat, which just concats 2 of them. I'm going to take my multiplication output, put it in the middle here. Now I'm going to examine this first concat. Now the second string is being determined by the output of the thermometer in this particular case, so I don't get a choice to put it in. But over here, I can put I'll put temp over here. And since this is displaying in Celsius, I'm going to do a space and a C over here. And this one here is my humidity reading. So let's call it humid. And the third one, I'm going to do a space and a percent. By the way, I put 1 space after the word humid, and I put 2 after the word temp on this one over here because there's one more letter in the term humid. And so now I'm going to take the outputs of these and put them back to line 1 and line 2 respectively. Save my project. Upload it to the Arduino. And now as you see, I've got a display that says temp and humid. So this is starting to look a bit better. In fact, this is looking pretty well the same as our original project did. But as I said, we're going to improve the project. Now one thing is my display is currently in centigrade. Perhaps I'd like to make it in Fahrenheit. So let's see what we would do there. We'll close the core and go to XOD units. And the very first one is C to F, Celsius to Fahrenheit. So all I need to do is bring that up. This is the temperature output of the thermal sensor. Let's delete that. Put its input and its output. So the input is Celsius, the output is Fahrenheit. You can do File and Save and upload to Arduino. Okay, it's uploaded to the Arduino, and now my temperature value, as you can see, is being displayed in Fahrenheit, although I haven't changed my concat statement, so it still says C at the end. Obviously, I could go back and change that to an F. But the whole intention here was to use the little push button that I put onto this circuit board in order to switch between Fahrenheit and Celsius. So let's see how I would do that. Let's go to the common hardware, and we'll get a button. Now the beauty of push buttons in XOD is it's already done the debouncing for you, and that's actually a very useful thing. Now the problem, of course, is I've got a push button, and so when I press it, it's going to go to one state, and when I release it, it's going to the other one, and that's what the output is going to be. It's either going to be false or true, depending on whether the button is pressed. Now, what I'd really like to do is I would like to make this button toggle. Now the first thing I want to do with my button is set its port. Now I've connected it to pin 2, so its port's going to be number 2 here. Now, what I'm going to do to make this actually toggle is I'm going to add a core element. I'm going to add what's called a flip-flop. Now, for those of you not familiar with the term, a flip-flop is a very basic logic gate. When it's sent a signal once, it turns to one logic state. The next time it flops to the other logic state. Sort of why it's called a flip-flop. In fact, there are some types of computer memory that are basically a series of flip-flops. So, I'm going to use the TCL input on my flip-flop and connect my button to that. Now if you look at the flip-flop, you'll see TCL is where the pulse that toggles the flip-flop is in. I'm going to disconnect this right now. And so remember, this output over here is going to be Fahrenheit. This one back here is still Celsius. So what I want to do is determine whether I'm going to select Fahrenheit or Celsius. And I'll do that with another core node, an if-else. Now, if-else is just like the statement we're used to in our Arduino coding. Why don't we just move this stuff up a little bit over here? It's getting a bit busy down here. I'll put it down here, I guess. Now, I've got two inputs on my if-else and an output over here. So one of the inputs on my if-else, actually I want to move that up. Going to be coming from this Celsius to Fahrenheit conversion. The other one I'll run directly, from here. So these are my two possible inputs here. The output I'm running to here, and I'll run this to the condition. So what's going to happen is the flip-flop is going to hold the state of the button, so it's either going to be set to a 1 or a 0. It's going to apply the condition to the if-else, and in one condition, it's going to give me this line over here, which is my temperature in Celsius. In the other condition, it's going to give me this line over here, which is my temperature in Fahrenheit. Maybe move this up so those lines look a little prettier. Let's save that and deploy it and see if it works. Okay, it's deployed. And as I press my button, you can see here I'm displaying in Celsius. If I press it again, I'm displaying in Fahrenheit. And so that works, although I still have one problem. My display still always says Celsius no matter what unit I'm using. So let's go and fix that. Now we're going to use another if-else on here, except not the same one. This is an if-else string. So let's drag the if-else string over here. And I'm going to use the same condition as this, so I'm going to use that same condition and drag it over here. Now instead of using inputs for true and false, I'm actually going to place values in here. So in true, I'm going to make this Celsius, or a C, and false, I'm going to make it a space F. Now the only difference with the if-else string is that it outputs a string. So I'm going to take the output here and I'm going to bring it over to here. Let's just move this so we can see it because it doesn't show very well what this is connected to. Okay. Alright, so if you look at my concat 3, the only thing in here I have is the temperature. The other two are being controlled. The first thing is the actual temperature, which will be either Celsius or Fahrenheit, depending on the state of the push button. And the second one over here is the last part of the display, which is going to be C or F, depending on the state of this if-else string. So let's go and save that and deploy it. And so now, as you can see, I've got the desired effect. I can click between degrees Celsius and degrees Fahrenheit. And that just about completes my project. The only thing I'm noticing, you'll notice these displays flicker quite a bit, and that's because my DHT22 is continuously being pulled. I don't really need to do that for room temperature. If I just took the temperature every few seconds, I could get rid of that flicker and make it a more practical display. So let's do one last thing. You remember our square wave from the first demo. I'm going to add one in over here. I'm going to go into its value. I'm going to set it to a value. I'm going to set it to 5, which means every 5 seconds. It doesn't matter. You could pick something lower or higher, but again, it's room temperature. Every 5 seconds will be quite adequate. I'm going to connect its output to the update pin on my thermometer, on my DHT22. So basically, instead of updating continuously, the DHT22 is now going to update based on this square wave, which is going to update it every 5 seconds. So let's save this and deploy it to the Arduino. And so now my display is a lot more stable. I can still switch between Celsius and Fahrenheit if I wish. But as you can see, I've eliminated the flicker because now it's just going to be updating every 5 seconds. Now there, it just updated the humidity slightly. But that's much more stable. In fact, this is a practical project now that you could actually put into an enclosure and use as a real product. built completely with XOD. Well, that about wraps it up for today's video on XOD. Now, this was just my introduction to XOD, so I'm going to do some other videos on the subject as well. In the next XOD video, I'll be getting deeper into the language, showing you more nodes that you can use in your programs, and also showing you how to use multiple patches in a XOD program, and even how to take a patch and use it as a node, which is a very powerful programming technique. So please stay tuned for that. Now, the best way to find out about new videos, either about XOD or anything else that I do, is to subscribe to the channel. So if you haven't done that, please do that. I would really appreciate that. Until next time, please take care of yourselves, and I hope to see you in the workshop again soon. Goodbye for now.